Okay, this is a 6.5 and 7.7 review. Number 8, calculators are allowed and they will actually be required on this one. You're not going to be able to do it without. So I'm going to run you through the process, and it's kind of time consuming, but it's what you need to do in order to answer the question. It says, at how many points in the closed interval does the instantaneous rate of change of f equal the average rate of change of f? So we want the instantaneous rate of change to equal the average rate of change. So that means inside here, because I want the average rate of change, I need to have the rate of change inside the integral. So if we think about this right here, this is going to represent a number, and this is going to be a function. So what we're going to be doing is we're going to be graphing this function and this number, and we're going to have to make sure that our window will show us this number, and then we'll count how many times they cross each other. So in order to set this up, I need to first be able to take the derivative. So let's look at the derivative. The derivative is the derivative of an integral, so I've got some of that fundamental theorem of calculus coming back to haunt me. If I want to take the derivative of this, I need to dump that inside and then realize that I've got a function of x in that upper limit, so I'm going to have to do the chain rule. So I have cosine of x squared times the derivative of x squared, which is 2x. So here's my f prime. This is my average, or excuse me, my instantaneous rate of change. So that's what I'm going to go put into y1. So I'll do that. You can do that. Perhaps, let me get to it, home, y equals so I have put that y1 in there. So now I need the average rate of change, which is going to be a number. So I'm going to go back to my home screen, and I'm going to do 1 divided by parenthesis pi over 2 minus that 0. There's my 1 over b minus a times the integral of, now I need the integral of that rate of change, and I just stored the rate of change in y1, so I can do y1 of x with respect to x, and I need it from a, which is 0, to b, which is pi over 2. Now I want a number for this because I need to get that number and store it in y2, and I also need to know what that number is numerically so that I can set my window. So I'm going to do a diamond enter and wait for it, and I get a 0.39742 on and on. So what I'm going to do is I need that number stored into y2. So I'm going to go up and grab it, hit enter, and then I'm going to store it by hitting that STO button, which is right above the on, and I'm going to store it to y2 of x. Now notice it's a 0.397 because we need to pay attention to that. If I go back to my y editor, I now have my instantaneous rate of change and I have my average rate of change, and they're both in the y editor. So my job now is to graph it on an appropriate window so that I can count how many times they're equal to each other. So I'm going to go to my window. X's are going to be the a to b, so that's a 0 to a pi over 2. The y's need to be above and below that instantaneous rate of change that I just computed, which was like 0.34 something. So I'm going to go from 0 to 0.5. I should be able to see it. So now if I graph, we can see there's that instantaneous rate of change. And then here comes the average rate of change. And we can see that we got 2 intersections. So the instantaneous rate of change equaled the average rate of change twice on that interval. So let's try the next one. Same setup. We need the instantaneous rate of change, which is f prime, which is the derivative of the integral, which means I'll plug that 2x into the inside, and then because I have the chain rule, I'll multiply by a 2. So there's going to be my y1. So in the home screen now, go back to Y editor, clear out that, and let's put the sign of 2x times 2. There's my y1. I need my y2 to be that average rate of change. So that average rate of change will be 1 over pi minus 0 times the integral from 0 to pi of that f prime that I just computed in y1. So on the home screen, I can do 1 divided by a pi minus 0 times the integral of y1 of x with respect to x from 0 to pi. Diamond enter again. Remember, we want to see what that decimal is. It looks awfully close to 0, so I'm going to go grab it. I'm going to store it into y2, and then I'm going to go to my Y editor and make sure that I can see everything. So I go to my window. I'm working from 0 to pi this time. So those are my x's. And y's, I need to see 0. So I'll go -1 to +1. Hit a graph. There's my instantaneous. And it looks like I have 1, 2, 3. Okay, last one. C, same issue. We need an f prime, which is the cosine of 2x times a 2, and I need a 1 over a pi over 2 minus 0 times the integral from 0 to pi over 2 of that f prime. So this is going to be my y1, this will be my y2. So back to the calculator, Y editor, clear, clear. I'll have a cosine of 2x times 2. On the home screen, I will now do 1 divided by a pi over 2 minus 0 times the integral of y1 of x with respect to x from 0 to pi over 2. Diamond enter so that I can see what the decimal is. Again, that looks pretty close to 0, so we will store that into y2 of x. Go to the home screen, or Y screen, excuse me, set the window. We need to see from 0 to pi over 2 in the x range, and we need to see above and below 0 on the y. So we've got that already. We can graph it. Here comes our instantaneous rate of change, and we can see that we crossed that 1 time.